Okay, so we're going to dive in now officially to chapter one. Just a little bit of an overview with a focus on homeostasis. All right, here we go. Homeostasis, right, is like coming into a state of equilibrium. So we're going to look at the basic requirements for life. We'll go through some definitions. We'll talk about how the balance in your body is controlled, and then we will differentiate between negative and positive feedback loops. You see this is highlighted. That means that you would likely see an exam question in which you need to do this. So you want to be able to really meet that objective for your assessment on your exam so that you can get that question right. There are 8 functions. You have to have boundaries, you got to move, you got to be responsive to your environment, you need to digest what you intake, your metabolism is going to convert that into something useful for you and move it around. It's then going to also, you're going to eliminate or excrete the substances that you don't need in the body. You need to be able to reproduce, with the caveat that it's a necessary life function in that for the life of the species to maintain, some of the species must reproduce. Growth, there's a life cycle, right? So you have plasma membranes that create boundaries or borders, and our skin is what separates us from the outside world, and so it has a lot of important functions in homeostasis, thermal regulation. It's very important. The muscular system allows us to interact with the environment. Our skeletal muscles specifically, our cardiac muscles are moving the oxygen and nutrient transport via blood, and then our smooth muscles are allowing us to have movement that it contributes to digestion and elimination. We need to interpret our environment, so we need to have a sense of what's coming in and then responding to that. So this is our perception or our sensory input and then our response. For example, when I touch the hot stove, I quickly move my hand away, right? Without even thinking about it. Your breathing rate will respond based on what you're doing with your skeletal muscles. Different environmental circumstances will affect your breathing rate, and the balance in your body or the homeostasis of your body will have your breathing rate will have a response based on all those contributing factors. What about digestion? Simply breaking down food into simple molecules so that they can be transported via blood. Metabolism is a chemical reaction that occurs in the body cells. So this is like catabolism is the breakdown. Anabolism is a synthesis of molecules. These terms sometimes come up again. So you don't need to memorize them anyway. I have like a mnemonic or a way of memorizing that, but I don't think it makes sense and I don't want to use it, so let's skip it. But anyway, so just know that you have to make and break molecules, and that's what your metabolism is, right? So when you talk about someone with a high metabolism, the idea behind that would be like that they can really efficiently break down their molecules and synthesize it high, fast rate, like we think faster kind of regeneration or turnover and such. Okay. What about excretion? That's simply the removal of waste. This is very important. If you're not able to remove waste from your system, right, your system will be compromised, right? You'll build up a toxicity. So, the ability to evacuate and eliminate is vital, right? It's as vital as intaking the food. We have to intake the food. We have to use it on a molecular level for our organ systems, and then we have to get rid of the byproducts that we no longer need. Okay, urea is the breakdown of proteins. Carbon dioxide is the byproduct from metabolism, and feces is the unabsorbed food. Reproduction. So we have at the cellular level, that's the division of cell growth and repair. So you're like, for example, your bones are constantly dividing and turning over again. And that gives us the ability to shape bone, or bones can be thick or thin based on how much tension we put on them or how much weight bearing we do. So if we walk more, we're going to have thicker bones in our lower extremity. If we lift weights, we're going to have thicker bones in our upper, lift weights like bicep curls, etc. We're going to have thicker bones in our upper extremities. So on the cellular level, things are divided and reproduced. On the organism level, it would be the reproduction of the species continuing with offspring. Everything increases in size on the organism level, right? So we start out inside the womb on a molecular level. The cells grow, the cells become molecules. It's like that organization of systems we went through until it gets to the baby, and the baby is born, and then that part actually continues to grow and change. So all cells depend on all the organ systems. We're going to look at these 4, right? All of them are necessary, but we have 4 out of 11. Excuse me, I'm going to go back. 4 out of 11 that we need to cover this semester. Right. Oh, what about it, the interrelation? So just keep in mind that although we are going to be looking at each body system separately, they function together, right? Everything's interdependent. So we look at it, we're just trying to chunk it up on some way to digest the material, to intake a certain amount of material at a time. But we want to overall just be acknowledging that each system interplays with each other. So, homeostasis, what is it, right? Rote definition here is maintaining a stable internal condition despite the external environment or situation. So this is a dynamic state of equilibrium, meaning that it will change, right? It'll change and adjust minute to minute, moment to moment, right, as needed. All organ systems contribute to and maintain our equilibrium or homeostasis. We need this for the right amount of nutrients, oxygen, water, to maintain our body temperature that's appropriate, right? So all these are important for sustaining life. Body temperature, I think, is really accessible mentally. So let's talk like you can't overheat the system. You can't cook your internal organs, nor can you let anything cool down to the point where it's not functional. It's not going to operate. So body temperature is really important beyond the level of I'm more comfortable wearing a sweater in this weather than not wearing a sweater. Okay. Appropriate atmospheric pressure. When you are inhaling and exhaling, right, you're changing. There's a pressure change that's happening within the lungs. You need to maintain a certain amount of pressure for your blood, for example. So your blood pressure against your arterial walls is important, and that's important for the whole system. So like you can imagine that if my blood pressure is not sufficient, right, then I'm not going to be delivering the nutrients and the oxygen in the way that my body needs it, right? So so these are all part of surviving. So this is a beautiful illustration. We have something that is in homeostasis or balance, and then we have something that takes it out of balance. Let me see what I can do here. Okay, so something changes it, right? It throws our seesaw here into an imbalance, and the change is detected by a sensor in the body. Okay, and then that information is sent towards the control center, which is like your brain. There can be other parts, but let's just think of like the brain for this example. And the brain is then going to make a decision. It's going to synthesize that information and say, okay, this is how we're going to change things in the body. We're going to make an effect on them so that we can now influence what's happening on this scale and bring us back into balance. Okay, so back into this level. So if I look at this example, okay, so we're in homeostasis, normal sugar level, glucose levels. There's our number for it. You'll have to probably memorize that later, next year or the year after. So homeostasis, normal levels, but then there's an imbalance. So we're going to say that there's too much sugar, there's too much glucose binding in the body, and that is going to be detected by the pancreas. Okay, so the pancreas is going to have a response, right, about this. It's going to say, okay, I have to release insulin into the blood, right? So it makes a change in the system, right? And when it makes that change, it causes the liver to take up the glucose, right, and store it as glycogen. So you're moving the sugars, into the liver. You're changing their structure so that they're out of the system of the blood level. Okay. The body cells will take it up too. So because the body cells in the liver are taking up those sugars, the blood where the imbalance is existing or locating, right, out of homeostasis, that is going to go down, right? It went somewhere else. It was in the blood and then it went here to the cells and went into the liver. So that allows us to come back into homeostasis. Okay. You could have low blood glucose levels, right? In that case, if you're